Hello, good morning all. For our video this morning, we're going to take up measures of dispersion. Okay, so we limit only to the three common measures of dispersion, which is the range, the variance, and the standard deviation. So we start off with the range. And then, by the way, our presentation here would be divided into ungrouped data and grouped data. So first we have the range of ungrouped data. So the range is the difference between the maximum value and the minimum value in a given data set. So the formula for finding the range depends on the data type. So for ungrouped data, the range is simply the highest value minus the lowest value. Now for grouped data, the range is equal to the upper limit of the highest class minus the lower limit of the lowest class plus 1. So we can understand that better by the use of an example. So for example 1, compute the range of the following sets of data. So for A, we have all 5s. So our range here would be equal to the highest value, which is 5, minus the lowest value, which is 5, giving us a range which is equal to 0. Now for the second number, the range would be equal to the highest value, which is 8, minus the lowest value of 3, giving us a range of 5. Now for the third set, we have the range is equal to 6 minus the lowest value of 4, giving us a range of 2. Okay, so it's very simple. Now, for the range of grouped data, the range is the difference between the maximum value and the minimum value given in a data set plus 1. Okay, so we have here our example 2. Compute the range of the following distribution. Now take note that the highlighted values are the ones which we are going to use in our formula. Okay, so for our range, we have the upper limit of the highest class would be 5,499, and then the lower limit of the lowest class is 1,000, and then plus 1, giving us a range of 4,500. Now, the next measure of dispersion would be the variance. So the variance is the average squared deviations of the observations from their mean. The higher its value, the more dispersed the data is. Now we start with the variance of ungrouped data. Okay, so we have for population and for sample. So the formula for variance actually is just the same for the two, but the notations used are different. So the population, the variance is equal to sigma squared, which is equal to the summation of the squares of the deviation of the data and the mean divided by n. Whereas for a sample, our variance is s squared, which is equal to the summation of the squared deviations from the mean divided by n minus 1. So we have here our legend. Sigma squared is the population variance, mu is the population mean, s squared is the sample variance, bar x is the sample mean, n is the number of observations or data values, and x is our data value. So we have here 4 steps in computing the variance of ungrouped data. First is determine the mean of the n numbers. Number 2, for each number, calculate the deviation or difference between the number and the mean of the numbers. 3, calculate the square of each deviation and find the sum of each squared deviations. And 4, if the data is a population, divide the sum by n. If the data is a sample, divide the sum by n minus 1. Okay, so we have our third example. The following numbers were obtained by sampling a population. We have 2, 4, 7, 12, and 15. Find the variance of the sample. Okay, so the first step is to find the mean of the numbers. So the mean, which is equal to bar x, is the summation of x divided by n. So for the summation of x, we have, okay, so the mean is equal to, we have 2 plus 4 plus 7 plus 12 plus 15, and then our n would be, okay, we count 1, 2, 3, 4, 5. There are 5 data, so we have divided by 5. Okay, so this is equal to 40 divided by 5 is equal to 8. So we have a mean of 8. Now take note of that. Now in step number 2, calculate the deviation between the number and the mean. So we have now our x minus the mean. So 2 minus the mean of 8, we have 4 minus 8, 7 minus 8, 12 minus 8, and 15 minus 8. So we have here negative 6, negative 4, negative 1, 4, and 7. Okay? So the next step is to calculate the square of each deviation and find the sum of these deviations. So we're going to take the square of negative 6, and that would be 36. Negative 4 squared is 16. Negative 1 squared is 1. 4 squared is 16. And 7 squared is 49. So we have here our total would be equal to 118. Okay? Again, 36 would be negative 6 squared. 16 would be negative 4 squared. 1 is negative 1 squared. 16 is 4 squared. And 49 is 7 squared. Okay? So, your table now should look like this. Now we have this one. Now, because we have a sample of n equals 5 values, we're going to divide the sum of 118 by n minus 1. So, we have now 118, which is our sum, divided by 4. Okay? So, what is it? Okay. So, I still have to use my calculator to find the answer. So, we have 118 divided by 4 is equal to 29.5. So our variance S squared is equal to 29.5. So it's easy, isn't it? Now, we go to the variance of grouped data. So the variance of grouped data have more steps compared to the variance of ungrouped data. Okay, so we have here the formula. The population again and sample variance vary in the denominator. So for our population variance, we have again similar to the variance formula for ungrouped data, but this time we already have an F, which is the frequency. Same also for our sample. Okay, so we have here our frequency. Same values actually as of the ungrouped data. Now we have the steps in computing the variance of grouped data. So the first one is to solve for the mean. So calculate the midpoint because we have here an interval already. So x would be upper limit plus the lower limit divided by 2. Second step is to multiply the frequency by the midpoint, would be f times x, and get the sum or the summation of the product of f and x. Third step is to calculate the mean by dividing the sum in step 2 by the total frequency n, or that would be in formula form the summation of the product of f and x divided by n. Now, the fourth step, this one here now would be the start of computing for the variance. Subtract all midpoints by the mean. That would be x minus bar x. Number 5, it was square the results in step 4. That would be now x minus bar x raised to the power of 2. 6 is to multiply the result of step 5 by the frequency of each class interval. And then we're going to add the results. In step number 7, divide the result of step 6 by n minus 1 if it is a sample, and by n if it is a population. Okay? So we have here our example number 4. Find the variance of the following monthly income of a sample of 64 P families of a certain barangay. So we have here now our data in interval form in the frequency. So we're going to illustrate each step here. So first, we need to solve for the mean. So we're going to calculate the midpoint, which is x is equal to UL plus LL divided by 2. Okay, so for the first one we have, so this will be our midpoint x. So the midpoint would be equal to, I'm going to write that here for the first few lines, that would be 1000 plus 1499, and then we have here divided by 2, which gives us 1249.5. Okay, so for the second we have 1500 plus 1999. Okay, the sum would be divided by 2, and that would give us 1749.5. Okay. So we can go on like this until we reach the lowest part. However, we can also simplify things by just adding our C, which is the class width, to our values here. So how do we get the class width? We can subtract two lower limits which are successive, or two upper limits which are successive. So we're going to subtract 1500 by 1000. So our C is equal to 500. So we can build this up by just adding 500. So 1749.5 plus 500 would be 2249.5. And then next would be add another 500, so that would be 2749.5, and so on until we get the last one, which is 5249.5. Okay, so that is our deviation from the this is our midpoint x. Okay, so that would be our midpoint. So in the next table we have, okay, so here now would be, we're going to multiply the frequency by the midpoint. Okay, so we have here our f times our x. Okay, so this column here, this is the one that we solved in the previous slide. Okay, so the first one would be f times xm. This would give us, okay, f times x is 6247.5. Okay, 6247.5. We simply multiply 5 times 1249.5. So next would be 12,246.5. Again, this is when you multiply 7 by 1749.5, and so on. So you keep multiplying this until we have the last. We have here now 15,748.5. Now, adding all this together, then we get a sum of 181,470. Okay, so we have here now the complete table. So our frequency, our midpoint, and then the product of f and x. Now, step number 3 is to calculate the mean by dividing the sum here of 181,470 by the total number of data, which is n. So here we have our mean would be equal to 181,470 divided by the mean at the n of 60, giving us a value of mean would be 3,025. Okay, so we have the mean is equal to 3,025. Now, after solving for the mean, then we're now going to proceed with finding the variance. Now, please take note that the mean is very, very important, because if the mean is wrong, then the next steps would be also wrong. Okay, so we go to step number 4, which is to subtract all midpoints by the mean. Okay, so we have here now our columns, the frequency, and the midpoint x. So we're going to subtract 1,249.5 minus the mean of 3,025. Okay, so here we have the midpoint minus the mean. So it's now 1,249.5 minus the mean of 3,025, which gives us negative 1,775.5. Okay, so the next class would give us negative, okay, so this will be 1,749.5 still minus, okay, 1,749.5 minus the same mean of 3,025, and this would be negative 1,275.5. Okay, so the third interval would have a negative 775.5, and so on. Keep doing that until we have here now our 2,224.5. Okay, so you can check that out. Now, the next step would be, okay, so we now have our midpoint minus the mean. The next step would be to square the results of step number 4, which is the this column here, the last column. So we will have x minus bar x quantity squared. So this will just be equal to negative 1,775.5 raised to the power of 2, and that will give us 315,000 or 3,152,000, okay, 400.25. Okay, the second one would be 101,626,900.25. So you keep doing that, you square this, okay, you raise to the power of 2 to write it here. Then of course, then we have here for the last line, this is equal to 4,948,400.25. Okay, so this will be the result of that table. So again, this is our x minus the mean, and this is the square of x minus the mean squared. The last column would be to multiply the frequency in this, giving us this last column. So this will be f times x minus bar x quantity squared. Okay, so multiplying 5 in what's this, 3,152,400.25 gives us this number, 1,576,2001.25. Now 7 times this, okay, 7 times this number would give us 113,883,01.75. And then for the last row, we will have 148, okay, 45, 200.75. Now, when you have all the numbers, then you get the sum. So, the sum would be 70712515. Okay? So, here is the completed table. So, we have here again our x minus bar x. This is the square of x minus bar x. And this is now f times x minus bar x squared. Okay, so our table is now quite complete. Now, okay. Step number 7 is to compute the variance. Divide the result of step 6 by n minus 1 if it is a sample, and by n if it is a population. Okay, so from step number 6, we have, okay, since this is a sample, then we use the notation s squared. We have here 70712515, okay, and then divided by our n minus 1, so we have 60 minus 1. So that would give us our standard deviation, the variance of, okay, let me compute this. So we have now 70712515 divided by 59. It gives us 1198. Okay, our S is 1198. 1,198,517.20. Okay, so it's quite a long process, but it's not that difficult. Okay. So next we go to the last measure of dispersion, which is our standard deviation. So the standard deviation of both ungrouped and grouped data is just the square root of the variance. Its lowest value is 0 and it cannot be negative. So what if we have our variance, we simply take the square root in order to find our standard deviation. Okay, so the formula for a sample and for a population are both similar. So it's just the square root of the variance. So for example 4, since the variance is equal to 1,188,517.2, then the standard deviation will just be the square root of 1198517.2. So our standard deviation is equal to 1094.77. Okay, so I guess that would be all. Thank you so much for listening.